Now, rational exponents is the exact same thing as regular exponent property. Same principle. I think it's the third, fourth page, like that. If I have the same base, add the exponents, just like regular exponents. The only thing is, you guys aren't going to like this because it involves fractions. Okay, you'll see it in the next section why we're doing this. Next, I would highly suggest at this point in your lives to do what with fractions? That's right. Put them in your calculators. Okay. I'm not going to take time to reteach fractions. Take like a week to have you guys do fractions. 6.4 part 1. Okay, 6.4 part 1. I think page 4, 5. Okay, when you put fractions in your calculator, you never know when you're going to, your calculator is a very good defender of PEMDAS. You never know if it's going to do what you want it to do, what you think it's going to do. I highly suggest you put all fractions in parentheses. And you should have a calculator in front of you. So, yes. Do I what? Yes, I do have batteries if you need them. All right, just give it to me at the end of class. Or take another one for now. All right, so I've got 1/2 plus 3/2, and actually you should be able to do this one in your head. I get 2. So this becomes 3 squared, and if you want to multiply it out, 3 squared is what? Good. You don't have to multiply it out. I'm looking for the property of this. Okay? I'm not grading you on whether you can take 3 squared. Okay, when I have power of a product, when I have a number outside of parentheses, what do I do with the exponents? Multiply it. Okay, for example, I take the 2 that's outside of the parentheses and I multiply it to 3/2. What do I get when I do that? 6/2, which is 3. But I'm going to put in my calculator because I don't want to deal with fractions. 3/2 times 2. Now I get 3. So this is 4 cubed. And you can put 64 if you want. I don't care. Okay, then we have the power product property when we have different bases. What do we do? What? Plus sign. You add the exponents. Alex, Steven, focus. Heck, focus. Fantastic. Thank you. Okay, if I have 2 different bases, I take my exponent and distribute it to each one of them, right? If there's no exponent there, what do I have? 1. I have 9 to the first, 4 to the first. So if I distribute, I get 9 to the 1 times 1/2, or 9 to the 1/2, times 4 to the 1/2. There's a couple of different, there's an easier way to do this, and I should have showed it to you. Because we didn't do radicals yet. I could do what's in the parentheses first. 9 times 4 is 36 raised to the 1/2. What is anything raised to the 1/2? Anybody know? Huh? Square root. 1/2 is the same as taking the square root. Maybe you should put that up here somewhere. The square root of a number, there's a 2 there. We normally don't put it there. Square root of a number is that number raised to the power of 1/2. This is called radical form. This is called exponential form. Okay, that means 1/2, 36 to the 1/2, square root of 36, 6. Now, if you don't believe me, use your calculator. What? What is? Square root. We normally don't put the 2 there. We just put a radical symbol. Square root of any number is that number raised to the 1/2. We're gonna cover this in a few minutes, actually. So hang on. Well, maybe. Okay, I could take 36 raised to the 1/2, and I get 6. We could also go back to the original one, 9 to the 1/2, 9 raised to the 1/2 times 4 raised to the 1/2, and I'll get the same answer. Okay. So either way, there's going to be a lot of different ways to do these in the order. So whatever fits your way of thinking is more than acceptable. Okay, what about negative exponents? How do I get rid of negative exponents? How do I get rid of negative exponents? How do I get rid of negative exponents? Flip them. Okay. You should be thinking this as over 1 because it's like a whole number. So this becomes 1 over 25 to the 1/2. Okay. And what's 25 to the 1/2? 5. What do I do when I have a fraction with the same base? That's right, subtract the exponents. I have 6 to the 5/2 minus 1/2. 5/2 minus 1/2 is what? Use your calculators if you're having problems. That's right, 4/2. And what is 4/2? 2. What's 6 squared? Okay, you can stop at 6 squared. And what do I do if I have an exponent outside parentheses with 2 different bases? It's the same properties as you did yesterday. Only, yeah, you multiply each one, right? This has an exponent of 1. This has an exponent of 1. So you're going to take 1/3 times 1, 1/3 times 1. I'm going to get 8 to the 1/3 over 27 to the 1/3. Anybody know what 1/3 exponent is in radical form? It's the cube root. Okay. Now, we're not going to get to this until the next section, but this would equal, instead of a squared, we got a cube there. Cube root of 8 over the cube root of 27. These are actually perfect cubes, 8 and 27. Perfect cube of 8, a number that multiplies itself 3 times to get 8. You can do it. I know you can. How about 2? 2 times 2 is 4 times 2 is 8. How about 27? 3. 3 times 3 is 9, times 3 is 27. We're going to get to that next section, so radical form. All right, let's do some example problems. Are you ready? Are you ready? Are you ready? Okay, number 1. I have the same base, so I'm going to add the exponents. 1/2 plus 1/4. And what do I get? What's 1/2 plus 1/4? 3/4. I would use your calculators. Okay, number 2. I have a power outside my parentheses, so I'm going to distribute it to each exponent. So I get 8. What's 1/2 times 2? 1. Times what's 1/3 times 2? 2/3. And at this point, I mean, we can go on and simplify this. There's no need to until we get to radical form. You could leave it like this for now. Number 3. I'm going to take negative 1/4 multiplied to each one of the exponents. 2 to the 4 times negative 1/4 is 4 times negative 1/4. If I have a quarter and I have 4 of them, what do I get? A buck, right? Only this time you got to make sure it's negative. How about 3 to the 4 times negative 1/4? Same thing. This, you can go one step further. You have to go one step further. You have to flip it, right? 1 over 2 times 3. You could leave it like that or put it in as 1/6. We should have a quiz Friday. Wow. I really probably not. All right, I have the same base in a fraction. There's a 1 there. So I'm going to take 7 to the 1 minus 1/3. What's 1 minus 1/3? I have 3 pieces of pizza and I take out 1 piece. How many pieces of pizza do I have left? 2 pieces of pizza. Hey, it's showing up on my screen. I can't. You guys got to get some kind of X-ray. We do a hard one. These are not hard.